Hi, welcome back to AT Math. Today, 12.1, inverse variation. Inverse variation basically is y equals the k, which is a constant, over x. So, if I were to take y equals k over x, in order to get k by itself, I'm going to get rid of the divide by x. So instead of divide by x, I'm going to times by x. You times x to one side, times x to the other. Notice what happens. These, of course, cancel. The x comes over here, so now k equals xy. It's easier if you have an example. Take this. If I have xy, when x is 1, y is 20. When x is 2, y is 10. When x is 4, y is 5. Why is that? Well, basically I'm saying that y equals 20 over x. Now why is that? Because 1 times 20 is 20, 2 times 10 is 20, 4 times 5 is 20. And if you notice here, xy, I just did that. 1 times 20 is 20, 2 times 10 is 20, 4 times 5 is 20. So basically you have y equals k over x. If I plug it in, 20, the k, over the x, 20 over 1. 20 divided by 1 is 20. 20 divided by 2 is 10. 20 divided by 4 is 5, as shown here. See each one. So basically k equals 20. And if you plug it in, instead of y equals k over x, y equals 20 over x. Maybe a visual will help too. Y equals 20 over x is going to look something like this. Now why do you ask? Well, when x was 1, y was 20, so 1, 20. When x is 2, y is 10, so 2, 10. When x is 4, y is 5, 4, 5. When x is 5, y is 4, so you're going over 5, up 4. When x is 10, y is 2. And finally, when x is 20, y is 1. So it kind of looks familiar, doesn't it? Almost, in fact, like a exponential function. It looks like an exponential equation, but with one difference. When you have an exponential function, such as y equals 0.5x, you're going to have a gentle curve like this. And that's what you're going to have. But if you have y equals 20 over x, you have that curve, but look what happens. There's a second one. Now, why is there a second one? Notice how the inverse variation has two different graphs for the same equation. Basically, as the equation goes from positive to negative, it splits into two parts. So instead of doing this, it splits. And this part's like this, but then this part's like this. Like that. That is an inverse variation. So instead of one continuous line, sorry about the drawing, but I had to freehand it, it splits. So this part will go up, but then this part goes down, like this. That makes an inverse variation. So you have two lines off one equation. Now here's another. Now again, we're not worried so much about the visuals yet. We're just worried about making x and y equals the same thing. So if x is 3 and y is 40, well, x is 3, y is 40. 3 times 40 is 120. 5 times 24 is also 120. 6 times 20 is also 120. All three have to equal the same amount. If they're not, it's not a constant, and it's not going to work. It won't be an inverse variation. So notice here how I plug them in again. 3 times 4 is 120. 5 times 24 is 120. 6 times 20 is 120. And if you do the reverse, if you take 120 divided by 3, you do get 40. You take 120 divided by 5, you get 24. And 120 divided by 6, you get 20. Notice how 120 is a constant, so it is an inverse. So k equals 120. If I were to go ahead and give you a graph, just show you y equals 120 over x, notice how this forms a very sharp up and down line, but then it splits into this line here, because it's the inverse variation. Now, you try. Is this an inverse variation? The question you have to ask yourself is, if you multiply x and y each time, does it get you the same result? Go ahead and see. Go ahead, pause me. Let's see how you did. Well, as you do all three, notice how the first two make 168, the first one makes 168, the second one makes 168, but the third one only makes 162. Now, because they're not all three the same, it's not a constant. Notice how 168 is not a constant, because not all three are the same, so it's simply not an inverse variation. That's all. Now, if you have something like this, 5 times x times y equals 80, all you're going to do first is you're going to go ahead and get x and y by themselves. Well, to get x and y by themselves, 5's got to get out of the way. So instead of times 5, we're going to divide by 5 to both sides. Take a look here, divide by 5 here, divide by 5 here. You go ahead and divide both sides. This gets to be 16. This goes away, so xy equals 16. Remember, xy equals k, so basically together they make 16. So since there is a constant, there is an inverse variation. So all we're saying is that x and y combined make 16, and you could graph off that, but we're not worried about it yet. Now you try. Find the inverse variation. Basically get x and y by itself. Go ahead. Let's see how you did. So instead of times negative 24, I hope you divided by negative 24 to both sides. If you do that, 15 divided by negative 24, and you get negative 15 over 24. Since we can get xy on one side, it is an inverse variation. Now to graph an inverse variation, write and graph the inverse variation in which y equals 2 and x equals 4. Let's start with this. K equals xy. Well, if I know that x is 4 and y is 2, I'm just going to plug them in. So 2 times 4 makes 8. So k equals 8. Now that I know my constant, I'm going to use the equation y equals k over x. Well, again, don't worry about plugging the values for y and x here. Now we're just going to plug in the k. The k is 8. Now why do we just plug in the k and not the x and y? Because once you plug in the k value, we're making an equation. So it's going to be y over 8x, and you can actually graph or use an online graphing calculator or your own graphing calculator to get all the possibles. So y equals k over x if you plug it in. Y equals 8 over x. Now for us to plug it in, however, we're going to make a table. So what you do is you have y equals 8 over x. Just plug in some values. Again, the easiest values I can think of are negative 2, negative 1, 1, and 2. Why not a 0? Because if you plug in a 0, 8 over 0, anything divided by 0, remember, is undefined. We don't want that. Therefore, and find the y values by plugging the x value into the equation. So we're just going to go ahead and put 8 over negative 2, 8 over negative 1, 8 over 1, 8 over 2, and plug in the corresponding values right here. 8 over negative 2 is negative 4, 8 over negative 1 is negative 8, 8 over 1 is 8, and 8 over 2 is 4. Fill in the table like so. Plug it in, plug it in. So when it's negative 2, we're down to negative 4. When we're at negative 1, we're down to negative 8. When we're up over 1, we're up 8. Over 2, we're up 4. Notice how it's starting to form that, again, that curvy inverse variation line. Music application. The inverse variation xy equals 2400 relates to the vibration frequency y in hertz to the length x in centimeters of a guitar string. Determine a reasonable domain and range and graph this inverse variation. Use the graph to estimate the frequency of vibration when the string length is 100 centimeters. Long story short, lots of string instruments. Their sounds based on how long the string is, how tight it is, lots of factors. And one of them in this case is xy equals 2400. So they want to use the graph to estimate the frequency of vibration when the string length is 100 centimeters. Let me give you a little help here. So basically you start off with your 2400. You say, okay, xy equals 2400. Now remember, y equals k over x. Well, the k is 2400. So y equals 2400 over x. Then it says decide on a reasonable domain and range. It says length is never a negative. In other words, if you're measuring something, you can't have a negative measurement, so it has to be a positive. So they're saying x is going to be more than 0. And because x and y are both positive, therefore your output's going to be positive as well. So basically what they're saying is, talking about 100 centimeters, they're plugging in a couple different possibilities, the things that might work. So when x is 20, 40, 60, 120, when they plug them in, plot the points, connect them in smooth curves. So here you have guitar string vibrations. And notice how you have your length of string. Let's see, find the y value when x is 100. When you go over to x is 100, you plug it in. The frequency of vibration is about 24 hertz. Product rule for inverse variation. If x1, y1, and x2, y2 are solutions of inverse variation, x1, y1 equals x2, y2. Remember, this does not mean x to the first power. No, it's x1 means the first x. y1 means the first y. So the first x value, first y value, and x2 means the second x value and the second y value. In other words, what they're saying, if you have an x that equals 3 and y that equals 2, so the first x is 3 and the first y equals 2, and the second y equals x, find the second x second y is 2, what's the second x? Basically, here's what they're trying to say. Your first x and first y multiply make a value, and it's going to equal the value of two other numbers. That's the whole point. Well, if you have 3 times 2, that makes 6. And over here I have 6 times what is going to equal that 6? Well, let's just write it out. So 3 times 2 over here, and something times 6, and they all have to equal each other. Well, 3 times 2 is 6, something times 6, so we're just going to say 6. You could just put 6x. You don't have to put 6x second. If you do, that's fine. But it might be easier to put 6x, whatever makes you happy. Divide both sides by 6, and you get an answer of 1, meaning that the second x value has to be 1. And ask yourself, does 6 times 1 equal 3 times 2? And you're going to say, yes, it does. Now you try. Let x1 equals 2, y1 equals negative 6. So remember, these two together, what will they need to make y2 times negative 4 to equal each other? So in other words, these two are going to work together. And this times something times the y second will equal this. Try to figure out what that is. Go ahead. Let's see how you did. Notice how I had 2 and negative 6. 2 times negative 6 makes negative 12. So negative 4 times something is going to make negative 12. I can just divide by negative 4 to find out. And negative 12 divided by negative 4 is positive 3. So my second y value would be a positive 3 in order to make it an inverse variation. Now a physics application. Boyle's law states that the pressure of a quantity of gas X varies inversely as the volume of gas Y. The volume of air inside the bicycle pump is 5.2 inches cubed, and the pressure is 15.5 psi. Assuming no air escapes, what is the pressure of the air inside the pump after the handle is pushed in and the air is compressed to a volume of 2.6 inches cubed? In other words, here's your air pump, and here's your plunger way on top. It hasn't been pushed yet. And the air is right here. Now the air is a certain amount of pressure. Now as I push down on the plunger, it's going to, as you see, push the air into a more compact area. Now the air weight hasn't changed. It's just been squeezed. So it's going to be a higher pressure. But how much more pressure? That's what we're going to find out. Well, we're simply going to say, okay, the bicycle pump is 5.2 inches cubed. That's the entire volume, alright? And the pressure currently is 15.5. So you're going to times those together to figure out what that value is. And then when we squeeze down and the volume is only 2.6, the pressure obviously has to be more because you're pushing down. You're tightening it up. How much? Well, 5.2 times 15.5 on one side, and 2.6 times something. Well, 5.2 times 15.5, value together is 80.6. Over here, 2.6, we'll just say times y to the not y to the second y value. Divide both sides by 2.6. 80.6 divided by 2.6 is 31. So in other words, instead of only being 15.5 pounds per square inch, it's now 31 pounds per square inch. So it's twice as tight. Much more pressure. The pressure after the handle is pushed is 31 psi. Now, where would you use this in real life? Well, different tires, whether it's on a motorcycle, a car, or a bicycle, have different pressure. Not enough pressure, tire goes flat. Can't use it. Too much pressure, boom, it blows up. Someone gets hurt. So that's why you always want to measure the amount of, read on your tire, whatever tire you're using, how much pressure it can handle. And then you take a pump, hopefully with a gauge. As you pump it, you check to see where your lever's at. And when you get to the right amount, stop, go ahead, take it out, and cap it off. And that's how you do that. But based on what kind of tire you have, you'll have to have different types of pressure.